Hi students, I am Yadumurthy. You are watching Chemistry Class 11 Part 1, Some Basic Concepts of Chemistry. Students, if you are new to this channel, please subscribe the channel, and if this video and audio is helpful to understand the chapter, please press the like button. Now let us continue today's topic, stoichiometry and stoichiometric calculations. Dear students, stoichiometry is derived from the two Greek words stoichion and metron. Stoichion means element and metron means measure. So this itself only is telling element measure or calculate the reactants and products which are involved in the chemical reaction. We'll take one example. Combustion of reaction of methane. Methane CH4 is a gas. To CH4 added two molecules of oxygen O2, 2O2 is a gas. We'll get the product CO2, carbon dioxide is also a gas, and another one product will get two molecules of water. Here methane and dioxygen are reactants and carbon dioxide and water are products. In this equation, all the reactants and products are gases. So gases we can written as G. If suppose liquid, we can write it as L, and if it is solids, we can write it as S. Here the coefficient of 2O2 and 2H2O are called stoichiometric coefficients. Similarly, the coefficient for methane and carbon dioxide is 1 in each case. They represent the number of molecules, even moles as well, taking a part in the reaction to forming a reaction. According to the above chemical reaction, or according to this chemical reaction, CH4 plus 2O2 gives rise to CO2 plus 2H2O. We can derive it as 1 mole of CH4 reacts with the 2 moles of O2 gives 1 mole of CO2 and 2 moles of water. Even this reaction we can also tell like this: 1 molecule of CH4 reacts with 2 molecules of O2 gives 1 molecule of carbon dioxide and 1 molecules of water. I hope you are understanding the here. First step we are taking as mole, and the second step we are taking as molecule. Now in the third step, 22 in liter 22.7 liter of methane reacts with 45.4 liter of oxygen O2 gives 22.7 liter of carbon dioxide CO2 and 45.4 liter of H2O. Now liter we can go into convert gram. So 16 gram of methane reacts with 64 grams of O2 gives 44 gram of CO2 and 36 gram of water. From these relationships, we can interconverted the reaction as like this. Mass gives through moles. From the moles we can come to know number of molecules. Same reversibly, number of molecules gives moles, moles gives mass. So here density is equal to mass by volume. Now we'll go for limiting reagent in stoichiometry and stoichiometric calculations. Many times reactions are carried out with amount of the reactants that are different than the amount as required by a balanced chemical equation or reaction. In such a situation, one reactant is more than the amount required by balanced chemical reactions. The reactant which is present in the least amount get consumed after some time, and after that further reaction does not take place. So whatever be the amount of the other reactant, since the reactant which gets consumed first, so limit the amount of product formed, and is therefore it is called limiting reagent. The reactant which gets consumed first limits the amount of the product formed, and is therefore is called limiting reagent. In performing stoichiometric calculations, this aspect is also to be kept in mind. So reactions in solutions. What are the reactions involved in different solutions? Majority of the reactants in the laboratory are carried out in solution. Therefore, it is very important to understand how the amount of the substance is expressed when it is present in the solution form. The concentration of a solution or the amount of the substance present in its given volume can be expressed in many of the following ways. One is either mass percent or weight percent or mole fraction or molarity or molality. Now we'll discuss one by one in detail what is mass percent, what is mole fraction, what is molarity, and what is molality. Okay, now we'll take mass percent. Mass percent is obtained by the mass percent is equal to mass of the solute in mass of the solution. So mass of the solute divided by mass of the solution, that we have to multiply with 100 will gives mass percentage. Here one example we are going to take. A solution is some X solution. A solution is prepared by adding 2 gram of a substance A, that we can 2 gram of substance is A, and to 18 gram of water. 2 gram of substance we added to 18 gram of water. 2 gram of substance is we can call it as A, and now we have to calculate the mass percent of the solute. See, first we know that mass percent is equal to mass of solute divided by mass of solution into 100. Here mass percent of A is 2 gram, that is substance. Mass percent of A is equal to mass of A divided by mass of solution A into 100. See, mass of solution A is 2 gram divided by mass of solution A is 2 gram plus 18 gram of water into 100. We'll get 2 gram divided by 2 gram plus 18 gram is 20 gram. 2 gram divided by 20 gram multiply with 100, we'll get 2 will be cancelled, then we'll get 0 will be cancelled, then we'll get only 10, that is 10%. See, mole fraction. Now mole fraction. Mole fraction is the ratio of the number of moles of a particular component to the total number of moles of the solution. Mole fraction is the ratio of number of moles of a particular component to the total number of moles of the solution. If a substance A is dissolved in substance B, and this number of moles are Na and Nb, we can represent it, then the mole fraction of A and B are given as mole fraction of A is equal to number of moles of A divided by number of moles of solution. Number of moles of solution is equal to Na divided by Na plus Nb. You can see on this slide mole fraction Na by Na plus Nb, and same way mole fraction of B, number of moles of B divided by number of moles of solution is equal to Nb divided by Na plus Nb. So now molarity. How to calculate the molarity? What is the definition of molarity? We'll come to know by studying this. molarity. Molarity is defined as the number of moles of the solute in 1 liter of the solution. Molarity can be denoted by M, capital letter M. Molarity, again I will repeat definition of molarity. Molarity is defined as the number of moles of the solute in 1 liter of the solution. Suppose we have 1 molar solution of substance, for example sodium hydroxide, and now we have to, from 1 molar of solution, 1 molar solution of sodium hydroxide, we have to prepare 0.2 molar solution. How? So now we'll study how to prepare 0.2 molar solution by using 1 molar solution of sodium hydroxide. Here 1 molar NaOH means 1 mole of NaOH present in 1 liter of solution. Same way, for 0.2 molar solution, we require 0.2 mole of NaOH dissolved in 1 liter of solution. To make 0.2 molar solution from 1 molar solution, we have to take that volume of 1 molar NaOH solution which contains 0.2 mole of NaOH solution and dilute with water to 1 liter. Now how much volume you have to take now? So, from the concentrated solution, from the concentrated solution which contains 0.2 moles of NaOH can be calculated as, if 1 mole is present in 1 liter or 1000 ml solution, then 0.2 mole is present in 1000 ml divided by 1 mole into 0.2 mole solution. So we'll get 200 ml solution. So 200 ml of 1 molar NaOH are taken and enough water is added to dilute it and make it up to 1 liter. So this will give 0.2 molar solution of NaOH. Generally, to calculate of molarity, we can use the general formula M1 into V1 is equal to M2 into V2. Here M and V are the molarity and volumes. In this case, M1 is 0.2 molar and V1 is 1000 ml. M2 is 1 molar, V2 you have to calculate. So now we have to substitute in this formula. M1 0.2 m into 1000 ml equals to 1.1 molar into V2. So therefore V2 is equal to 0.2 m into 1000 ml divided by 1 m. We'll get 200 ml. Note that number of moles of the solute NaOH was 0.2 molar in 200 ml, and it has remained the same even after diluting to 1000 ml. Okay, so here we'll have one question. Calculate the molarity of NaOH in the solution prepared by dissolving its 4 gram in enough water to form 250 ml of solution. See, we know that molarity is number of moles of the solute divided by volume of solution in liters. Here mass of NaOH divided by molar mass of NaOH divided by volume of solution in liter. So mass of NaOH is 4 gram and molar mass of NaOH is 40 gram divided by 0.25 liter, that is volume of solution in liter. So 4 gram divided by 40 gram will get 0.1 mole divided by 0.25 liter. We'll get 0.4 molarity. So what is the answer? 0.4 is the molarity. So when we are dissolving 4 gram of NaOH in 250 ml water. So now we'll here in molarity, Solution is depends on the temperature because volume of the solution is temperature dependent. So now what is molality? Molality is defined as the number of moles of the solute present in 1 kg of the solvent. So molality can be denoted by small letter m. Molality is defined as the number of moles of the solute present in 1 kg of solvent. So this molality we can understand by go through the one problem. The density of 3 molar solution of NaCl in 1.25 gram per liter. Now we have to calculate from this molality of the solution. See here m is equal to 3 mole per liter. Okay, it is given in the problem. See, mass of the sodium chloride in 1 liter solution is equal to 3 into 58.5. 58.5 is the molar mass of sodium chloride. So 3 multiply with 58.5 will get the answer 175.5 gram. So mass of the water in solution is equal to mass of the 1 liter solution is equal to 1000 into 1.25. 1.25 gram is per ml is equal to 1250 gram. Okay, mass of water in solution. Now we have to minus this 1250 minus 175.5 gram of mass of NaCl in 1 liter solution will get 1074.5 gram. Okay, 1075.4 gram. So now molarity we have to calculate from this. So now moles of the number of moles of the solute divided by mass of the solvent in kg. 3 mole divided by 1.0745 kg will get 2.79 molality. We know, see here, molality of a solution does not change the temperature since mass remains unaffected with temperature. So this is the stoichiometry and stoichiometric calculations. I hope you students are understood this topic. If the video is helpful, please press the like button, and if you are new to this channel, please subscribe to this channel. Thank you.